Hello student, welcome to next lecture for numerical methods and its applications. In last lecture we have discussed forward differences. If we are given a function y is equal to f of x and finite set of values of x that are equally spaced, initial values x0, x1, x2, xn, these are n plus 1 values of x which are equally spaced, means the value xi plus 1 is obtained by adding h in previous value of x, that is xi plus h, where h is the difference between any two consecutive values of x. Xi plus 1 minus xi is h for I belongs to 0 to n minus 1. Hence, these values are equally spaced and corresponding to these values of x, we will get values of y. For x is equal to x0, we get y0 is equal to f of x0. For x is equal to x1, we get y1 is equal to f of x1. For x is equal to x2, y2 value is f of x2. yn is f of xn. These are the values of y. And forward difference operator delta is given by del f of x is equal to f of x plus h minus f of x. If we put x is equal to x0, then we get for x is equal to x0 del f of x0 is equal to f of x0 plus h minus f of x0. But what is x0 plus h? By this formula, x0 plus h is x prime. Hence, this is del f of x0. This means the value of del by 0, because f of x0 is y0. Del by 0 is f of x0 plus h is f of x1 minus f of x0. That is del y0 is equal to f of x1 is the value of y1 is equal to y1 minus f of x0 is y0. y1 minus y0. This is the definition of first order forward difference operator. Del f of x is equal to f of x plus h minus f of x. From that we will get these differences, first order forward differences for the points y0, y1 up to yn minus 1. Now we discuss backward difference operator. Backward difference operator is denoted by this symbol. Let y is equal to f of x be a function, then del f of x is given as f of x minus f of x minus h. If we are given n plus 1 values of x, suppose they are x0, x1, x2 up to xn, where all these values are equally spaced, means x1 is obtained as x0 plus h, x2 is given by x1 plus h, xn is given by xn minus 1 plus h. That is, relation between two values of x is given as xi plus 1 minus xi is equal to h. Difference between two consecutive values of x is h. Hence, h is a constant. These are equally spaced values of x. Corresponding to this value, we will get values of y. y0 is f of x0. If we consider x is equal to x0 in this equation, then we get y0. y1 is equal to f of x1. y2 is equal to f of x2. yn is equal to f of xn. Now we have this formula. Del f of x is equal to f of x minus f of x minus h. If we substitute x is equal to x1 in this equation, if x is equal to x1, then what we get? Del f of x1. First order backward difference. At the point f of x1 is at the point y is equal to, by this definition, f of x1 minus f of x1 minus h. But what is x1 minus h? x1 is equal to x0 plus h, hence x1 minus h is x0. This is equal to f of x1 minus f of x0. This is the value of del f of x1. Del f of x1 is y1, hence del y1 is equal to f of x1 is again y1 minus f of x0 is y0. Similarly, we will get del y2. If we substitute x is equal to x2 in this equation, if x is equal to x2, then del f of x2 is equal to, by definition, this is f of x2 minus f of x2 minus h. What is x2 minus h? See, x1 plus h is equal to x2, hence x2 minus h is the value of x1. This is equal to f of x2 minus f of x1. This is the value of del f of x2. What is f of x2? Value of y2. f of x2 is y2. Hence del y2 is equal to f of x2 is again y2 minus f of x1 is y1. Hence del y2 is equal to y2 minus y1. Del y1 is equal to y1 minus y0. Hence del yn. Therefore del yn is given by yn minus yn minus 1. These are first order backward differences at the point y1, y2 up to yn. We can find second order backward differences at the same points y1, y2, y3 up to yn. Del square y2 is equal to del of del y2. We know this value del y2. This is del of del y2 is y2 minus y1. Del distributes over addition. By distributive law, we get del y2 minus del y1. We also know these two values. Del y2 is y2 minus y1 minus del y1 value is y1 minus y0 equal to y2 minus y1 minus y1 minus y0. This is equal to y2 minus 2y1 minus plus y0. This is the second order backward difference at the point y2. Similarly, we get second order backward difference at the point yn. Del square yn is equal to yn minus 2 yn minus 1 plus yn minus 2. In similar way, we can find finite order backward differences at the point which are again finite in number y0, y1, y2 up to yn. Properties of this backward difference operator and forward difference operator are del f of x plus g of x is equal to del fx plus del gx. Similarly, backward difference operator distributes over addition. Del f of x plus g of x is equal to del f of x plus del g of x. is equal to a into del f of x, where a is constant, a is greater than 0 and a is constant. Similarly, first order forward difference operator of a into f of x is equal to a into del f of x. Third one, if c is constant, if fx is constant function, then f of x is equal to 0. Similarly, del f of x is equal to 0. Now we see how to prepare backward difference table. If we are given a function y is equal to f of x, then we prepare backward difference table. First column includes the values of x. Second column contains values of y, which is function of x. Third column contains values of first order backward difference at the point y is equal to f of x. In next column, there are values of second order backward differences, and in the next column, there are third order backward differences. Value of x is suppose x0, x1, x2, x3. If these are four values of x, then we get corresponding four values of y by using this function. Initial value is y0, which is obtained by taking f of x0. y1 is equal to f of x1, y2 is equal to f of x2, y3 is equal to f of x3. In the column of first order backward difference, initially we get del y1 is equal to y1 minus y0. In previous column, we know the values of y1 and y0. Del y2 is equal to y2 minus y1. Del y3 is equal to y3 minus y2. In next column, we will get second order backward differences. Del square y2 is equal to del y2 minus del y1. Next, second order backward differences, del square y3 is equal to del y3 minus del y2. We calculate the values of first order backward differences by using values in the previous column. Values of y0, y1, y2 up to y3. If we use these values, then we get for first order backward differences at the points y1, y2, y3. In next column, we will use these values to get values of second order backward differences at the point y2 and y3. And in last column, we get del cube y3 is equal to del square y3 minus del square y2. These are the third order backward differences. As we have four values of x which are equally spaced, these are four values of x which are equally spaced, we will get at most third order backward differences. We see one example on this. From the values of x and y, from the following table, then 40, then square 30, and then this to 450. We have given the values of x and y as I will write that values in column. Given values of x and y are 10, 20, 30, 40, 50. Corresponding values of y are 45, 65, 80, 92, 100. These are the values of x and y. What is the question? Construct a backward difference table from the values of x and y. This is the given table in the example, and find the values of del cube 40, del square 30, del raised to 4 50. See, these are 5 values of x and 5 values of y. Hence we get fourth order hence we get the backward differences of the values of y up to fourth order. First order backward difference is given as this initial value of x is suppose x0, its corresponding value is 45, plus value corresponding to x0 is equal to 10 is y0 is equal to 45. The value corresponding to next value of x which is 20 is y1 is equal to 65, x2 is equal to 30, corresponding value y2 is equal to next value is 80. Corresponding to x3 value, we get y3 value as 92, and for x4 is equal to 50, we get y4 is equal to 100. These are the given values. See, difference between two values of x is same. x0 minus x1 minus x0 is 10, x2 minus x1 is 10. Hence, x value is 10. In this example, value of x is 10, that is given. In third column, we get del y1, which is equal to, what is the formula? That is y1 minus y0. What is the value of y1? 65 minus 45, which is 20. Hence we get del y1 is equal to 20. Next value we will get del y2 is equal to, the formula is y2 minus y1. y2 value is 80, y1 value is 65. Hence difference is 15. 80 minus 65 is equal to 15. Next we get del y3 is equal to y3 minus y2. y3 is 92 minus 80, which is equal to 12. Last we get del y4 is equal to y4 minus y3, which is 100 minus 92 is equal to 8. In next column we will get second order backward differences. Del square y2. Del square y2 is del y2 minus del y1. This is what the formula. We know del y2 value is 15, del y1 value is 20, which is equal to minus 5. Del square y3 is equal to del y3 minus del y2. In previous column we have calculated these two values. Del y3 is 12, minus 15 is minus 3. Del square y4 is equal to del y4 minus del y3. Del y4 value is 8 and del y3 value is 12. This is equal to minus 4. In next column we will get del cube, that is third order backward y3 is equal to del square y3 minus del square y2. The values are minus 3 and minus 5. This means minus 3 minus minus plus 5, which is equal to 2. Del cube y4 is del square y4 minus del square y3. Del square y4 is minus 4 minus minus plus 3, that is minus 1. In last column we get 4th order backward difference. Del raised to 4. This is del raised to 4 y4 is equal to del cube y4 minus del square y3 is equal to minus 1 minus 2 is minus 3. This is the backward difference table for the given values of x and y. Construct a backward difference table for the function f of x is equal to x cube plus 5x minus 7 for x is equal to 0, 1, 2, 3, 4, 5. Find f of minus 1. See, these are 6 values of x are given. Difference between 0 and 1 is 1. Difference between 2 and 1 is 1. Hence the value of h is 1. We also have to find the value of f of minus 1. Minus 1 is at a distance 1 towards left from the point 0. We have given values of x as 0, 1, 2, 3, 4, 5. Hence, the value of h is 1 because the difference between any two consecutive values of x is 1. We have to find the value of f of minus 1. Means we consider x is equal to minus 1 in next case. But minus 1 value lies at a distance 1 from the point 0 towards left side. So we consider the value of x0 is minus 1 starting with minus 1. We consider the values of x as x0, x2, x1, x2, x3, x4, x5, x6. Hence there are 6 values of x and we consider backward difference table for these values of x. Given function is f of x is equal to x cube plus 5x square minus 7. First we find the values of function at this point of x and we prepare the table. X values of y is equal to f of x. The next column contains first order backward difference del f of x del square f of x del f of x del raised to 4 f of x. There are 7 values of x starting from minus 1. So we get 6th order backward differences. Backward differences of order at most 6. Which are the values of x? X value starts from minus 1 because we want to find this value f of minus 1. So we take initial value of x is minus 1 which lie at a distance 1 from 0. Next value is minus 1 is value of x0. x1 is 0. x2 value is 1. x3 is equal to 2. 5 is equal to 4 and x6 is equal to 5. Corresponding this value, we find the values of f of x. Put x is equal to x0, then we get y0 is equal to f of x0. What is x0? Minus 1. Okay, because x0 is minus 1. Initially, in second column, we will get the value of f of minus 1 because y is equal to f of x, y0 is equal to f of x0. That is what we have to find. y1 is equal to f of x1. f of x1 is f of 0. f of 0 value is minus 7. Next value of x is 1 and corresponding value is y2 is equal to f of x2. It is obtained by substituting x is equal to 2 in this function. Then we get that value is minus 1. Next value is y3. y3 is f of x3 means f of 2. f of 2 value is given by 11. For x4 is equal to 3. For x value of x as 3, we get f of 3 is y4 is equal to 35. For x is equal to 4 in this function, we get the value of y5 which is equal to 77. And for x is equal to 5, we get f of 5. That value is y6 and f of 5 is 143. In this column, we get first order backward differences. We will start from bottom of the table. Then y6 is equal to y6 minus y5. This is the formula for del by n. What is del by n? yn minus 1. Del y6 is equal to y6 minus y5. We know both the values. y6 is 143 and y5 is 77. Hence, del y6 is 143 minus 77. That value is 66. Next we get del y5. This is y5 minus y4. y5 is 77 minus y4 is 35. This is equal to 42. Next value is del y4 which is y4 minus y3. y4 value is 35. y3 value is 11 which is equal to 24. Next value is del y3 is equal to y3 minus y2. y3 value is 11 minus plus 1 which is equal to 12. Next value is del y2 is y2 minus y1. y2 is minus 1, y1 is minus 7, minus plus 7 which is equal to 6. Del y1. What is this value? y1 minus y0. We know the value of y1 but we don't know the value of y0 because we have to calculate that value from table after completion of table. So this value is unknown. Next column we get second order backward differences. Del square y6 is equal to, what is the formula? Del y6 minus del y5. Del y6 value is 66 and del y5 value is 42. Hence this difference is 24. Next we get del square y5 is equal to del y5 minus del y4. 42 minus 24. This value is 18. Del square y4 is equal to del y4 minus del y3. Del y4 is 24 minus 12 is 12. Next we get del square y3 is equal to del y3 minus del y2. 12 minus 6 is 6. Next we get del square y2. But this formula is what? Del square y2, del y2 minus del y1. We don't know the value of del y1. We have to calculate that value. In next column we get third order backward differences. Del q y6 is del square y6 minus del square y5. What is the formula? Del square y6 minus del square y5. Del square y6 value is 24 and del square y5 value is 18. Hence, this value is 6. Cube y5 is del square y5 minus del square y4. Means 18 minus 12 is again 6. Del cube y4 is equal to del square y4 minus del square y3. That is equal to 12 minus 6 is 6. Del cube y3 value is unknown because this formula is del square y3 minus del square y2 because del square y2 is unknown value. Hence, this is also unknown. See, all the differences in fifth column are constant. Del cube y4 is 6, del cube y5 is 6, del cube y6 is also 6. All differences are constant. Hence, the remaining difference is also constant. Del cube y3 value must be 6. So, in the next column, fourth order backward difference value are 0. If we try to find that value, del raised to 4 y6. What is the formula? Del cube y6 minus del cube y5. Both values are same. Del cube y6 is 6 and del cube y5 is 6. Hence, this difference is 0. Hence, all the backward differences of order greater than or equal to 4 in this table are 0 because third order backward differences are constant. The backward differences of next orders, that is backward differences of order 4 and 5 are 0. Hence, from the last column of this table, we will get the value of del cube y3 as del cube y4 is equal to 6. This value is same as del cube y5, del cube y6. All these three differences are constant. Hence, the next backward differences of order 4 and 5 are 0. Hence, the 4 and fifth order backward differences are 0. Also, as in the last column, 3 backward differences are 6, hence the remaining backward difference is also 6. Del cube y3 is 6. We have this value, del cube y3 is equal to 6. But what is the formula for del cube y3? This is del square y3 minus del square y2 is equal to 6. From out of these two values, we know one value, del square y3. Del square y3 is 6. Using this value in this equation, 6 minus del square y2 is equal to 6. This implies del square y2 is equal to 0. But what is the formula for del square y2? That is del y2 minus del y1 is equal to 0. We know this value, del y2 value is 6. Hence, 6 minus del y1 is equal to 0. Hence, del y1 is equal to 6. But what is the value of del y1? y1 minus y0 is equal to 6. We have the value of y1 equal to minus 7. Minus 7 minus y0 is equal to 6. This implies y0 is equal to minus 7 minus 6. Hence, y0 is equal to minus 13. What is y0? y0 is f of x0. But what is f of x0? f of minus x0 is minus 1, as the value of x lies at the end of the first column. x0 is initial value of x, and we have to determine the value of f of minus 1. So we find the value of f of x0, which is y0. This y0 value obtained as minus 13. Hence y0 is equal to f of x0, which gives f of minus 1. y0 value is minus 13. Therefore, f of minus 1 is equal to minus 13. Thank you, student.